Okay, welcome back, everybody. This is our 5th week out of school. Strange, we potentially have 7 more. I don't know. I never thought it would last this long. Hopefully, we get to come back at some point in time. I'd much rather be there than here. Not that I don't like my house, but I just would rather be actually working at. Okay, enough of me complaining. So what we're going to be doing today is we're going to be talking about limits to infinity, and there's a few different ways that you can go about doing these. One is algebraically, and the other is using Desmos and analytically look at the graph to figure out what the limit as it goes to infinity is. If the limit it doesn't exist, then you need to answer is dne. So let's take a look at this example. So we're looking at the limit as x approaches infinity of 3x cubed times 2 minus 5x cubed all over 2 minus 9x squared times 5x plus 2. So what I'm going to do first is I'm going to look at doing this analytically using Desmos. So I'm going to need to that actually as I'm entering it into Desmos. Just kind of dock these windows here. And oh, hey, yeah, let's do that. Better. All right, now entering this in, I'm going to enter it as 3 third times this is divided by square parentheses. All right, so now if I take a look at this function as it's approaching infinity, you can see that the function itself, as x is approaching infinity, the function itself seems to be approaching positive infinity as well. And as the function approaches negative infinity, like the function is approaching negative infinity, well, there's this weird little in the middle there. So since our two limits are different, that means that the limit does not exist. As it approaches in one direction, it's approaching positive infinity. There, cool, negative infinity. Now let's take a look at another one here. If they were both approaching, like as we were approaching positive infinity and negative infinity, as if they were both approaching the same value, like if they were both going down, both going up, then it would be either positive infinity or negative infinity. Or if it was approaching a specific value, say for example, it was approaching 5, that would mean that 5 would be the limit. So let's take a look at a different example. Okay. If the limit is infinite, so if it's going to infinity in either direction, state that the limit does not exist. So I'm going to take this function here, and I'm going to enter this into Desmos and evaluate the graph. So to do a cube root in Desmos, you want to bring up the keyboard function, and this is going to be underneath. So nth root. So we want to do cube root 8x to the 6th x 64. Outside of everything, divide this by x x second. Now, if we take a look at this analytically, if I zoom super close here, let's choose like a value. You can see that this looks like it's approaching. Let's see if I go far out. So it looks like it's approaching 0, and it's approaching 0 in both directions. This direction is approaching 0. In this direction, it's approaching 0. So as the limit's approaching infinity, the limit of the entire function is approaching 0. Okay. Let's go through another one because there's a few different types of these. Let's do infinity 3. And yeah, Desmos. Honestly, I think this Desmos is probably the easiest, but I'm going to go through. Okay, so we're going to do x to the 62nd divided by x to the 6th. All right. Now, as we're approaching negative infinity, the limit does not exist because of values of the function. As we're approaching positive infinity, the values of the function approaching negative 0.1 as value that. Oh, hey. The limit exists and does. Cool. All right. So that's going to be your assignment for this week. Is those limit questions. 15 on the assignment. Let me check. Yep, there's 15. You have until, for you guys, I'm giving you until Monday of next week, right, to get these done. If you need help, let me know. You send me an email, chat with me on Google Hangouts, set up a Google meeting, just, whatever. Let me know, and yeah, have a great day.